Okay, so this is section 7C of the iGCSE introduction topics. It's fission and fusion. So first of all, let's just talk about neutron radiation. So neutron radiation consists of a free neutron, usually emitted as a result of spontaneous, i.e. it just happens, or induced nuclear fission. They can start off a nuclear bomb or a fission reaction. Obviously, these neutrons travel around and can be dangerous. They could travel thousands of meters in air, but can be stopped or blocked by hydrogen-rich materials such as water or concrete. So what happens, or what's the use of all this? Well, in nuclear fission, in a nuclear power reaction, we use a reaction called nuclear fission. And two isotopes in common use for nuclear fuels are uranium-235 and plutonium-239, which you should know. And what happens is the nucleus splits into two smaller nuclei, often krypton and barium. So there's a ratio about 2/5 to 3/5 in the split. They are radioactive. They release generally 2 or 3 neutrons, which are released into the environment. And energy is also released, and the additional neutrons that are released may hit uranium or plutonium nuclei further in the rod in a nuclear reactor and cause them to split. And we call that a chain reaction. So these atoms are splitting, they're releasing energy, and the energy is in the form of kinetic energy. The neutrons slow down and they give up their kinetic energy into a thermal energy store. Now, we've also got to know all the different parts of a nuclear reactor. So we need to know about fuel rods and how they're a source of fuel. So they're the thing that splits. So it's a non-renewable source. There's a moderator in there which slows down the neutrons, which helps them meet another uranium atom. So it increases our probability of creating the fission process. That's often made of water or a block of graphite. You should know that. Control rods, they dip into the core of the reactor. They absorb neutrons. So prevent them splitting down into more atoms and slows down the process. So often they're made of boron, and a shield that's made of concrete or steel with thick layers to absorb the radiation. There is a heat exchanger in there, which is like a radiator. So we pump around hot coolant and it loses its thermal energy store by heating to another pipe, which then takes the energy away and goes to a steam turbine or generator and a transformer, and the steam pressure turns the turbine, which connects to the grid, which produces electrical energy or by an electrical process. Now, the other trendy idea is that we can have nuclear fusion. Well, fusion happens in the sun, but actually, fusion is a process where smaller nuclei make a larger one and release energy inside a star. And fusion is much harder to achieve than fission, as you have to overcome very strong electrostatic and proton repulsion. You have to push them very close together using pressure and temperature with fast-moving particles with a lot of kinetic energy until the neutrons take over and glue them together with this thing called the strong nuclear force, which you don't need to know at GCSE, but it explains why you can make these nucleons push together and stick. So if I get them close enough, it's sort of like a bit of an elastic thing that pulls them just together and binds them. You need to have an idea of some of the equations as well. So here we've got a fusion equation where 2 hydrogen make a helium. All of the protons and neutrons are accounted for, or 2 helium in this case make a bigger helium and 2 hydrogen. So you have lots of these processes going on in a star, which is just natural, and we're trying to do that on Earth in a fusion reactor. And you can see here we've got 2 examples for typical fission equations where a neutron has come in and hit uranium, producing then this barium krypton plus 3 neutrons. On this case, so this is the same one, but this time we've got xenon and strontium and 2 neutrons. So you can't like learn one, you've got to learn the idea. And again, it would be a fill in the gaps type question. So that is fission and fusion.